All right, now we're going to think about combining functions graphically. So here we've got two new functions, f of x, g of x, and we want to see what happens when we add them. Well, to help myself, I'm actually going to put these graphs together. So this looks like negative x plus 2. So I'm going to add a line in over here of my g of x. So we've got 2 here. At 1, we also go through 1, negative 2, 3. All right, so we've got this line here. So if I think about what happens when we add these, well, what we're doing is really, when we're adding f of x and g of x, we're adding the y coordinates. So at this, for example, when x equals 1, they both have a y coordinate of 1. So that means on my new graph, when I add them, I'll have 1 plus 1 for the y coordinate, which is 2. All of my points on this side, notice we've got a line, so we're changing all the points by a fixed rate. So when x is equal to 0, I also have the same points. I have the same y coordinate as 2. So when x is 0, that's up here at 4. And I can find some other points that match. When x is equal to negative 1, I have 5 plus 3. So at negative 1, that's going to be up here at 8. So let's say somewhere about there or so. When x is 2, now this is interesting. When x is 2, my y value here is 2, my y value here is 0. So that point didn't change. We've got a constant point there at 2, 2. When x is 3, I've got a y value of negative 1, and I also have a y value of 5. 5 plus negative 1 is 4. So notice we've got some symmetry going on here. So again, it looks like I'm still going to have a parabola, but my parabola has been shifted, and it looks like 1.5 is going to be my vertex. So at 1.5, I've got about a half plus something that looks like it's about, I don't know, 1.25, 1.3, something like that. So I'm going to be somewhere in this area. And so I've got another parabola that's been shifted over. So not only here we went from a vertex of 1, 1, we've shifted over to 1.5, we've also shifted up some. So let's go look on, if I want to verify this on Desmos, I need the equation of both of these. Well, my parabola here had a vertex of 1, 1. Let's see how it opens. I go over 1, up 1, over 2, up 4. That's a normal parabola, so I have an a value of 1. So this equation, my f of x, is 1, x minus 1 squared plus 1. So vertex, and then the rate that we go. We already said our g of x line is x minus 2. So if I want to graph these, I want to see if they look the same. If I added this to my picture, I would be over somewhere. So I'm adding these two values together. So I go up this distance plus about half more. So here. And then I had my other points. I had 2, 2, which stayed the same. I also had 1, 2, and then I had 0, 4, and I also had 3, 4. So it looks like I've got another parabola inside there. It goes like that. So let's look over at Desmos. We have our f of x, g of x, and as we can see, the addition is inside and moved over. And we can write the exact equation if we wanted to based on our vertex. All right, so now let's look at what's going to happen. Let me put in another page here. So, add page. I don't know that I can. Let's Let's do this. And then we can do this. Sorry. That didn't work. All right, well, let's go here and maybe I'll just move this down for a moment. Okay, so now if I want to think about where is this going to be undefined? Well, we know we can never divide by 0. So thinking about dividing by 0, g of x is equal to 0 when x equals 2. And I guess I didn't need to move my graph down after all. So we're undefined at x is equal to 2. The domain, what are the x values allowed when I subtract our two functions? Well, we had all reals for f of x. We have all reals for g of x. So when I subtract the two, I'm going to get a new function that still has all reals. It's going to be another parabola shifted over, but we'll have x such that x is an element of reals will be our domain. And that's looking at the graphs.